Hi, everybody. I am Aaron Witham, the Director of Sustainability at the University of Southern Maine. Before I kick things off for today's presentation, I just want to briefly introduce the rest of our team who's presenting today. We have John Martin from Elkus Manfredi Architects. We have Thomas Moore from Stephen Winter Associates. And last but not least, Walker May from Capstone Development Partners. To give you a broad overview of our project, Portland Commons is an ambitious mixed-use student residence, and it's in Portland, Maine. It's 8 stories, 580 beds, 385 units, and 220,000 square feet. It's already Passive House pre-certified, and it's in construction now, due to be complete next summer of 2023. Primary users of the building are going to be the upper end of undergraduate students, so juniors, seniors, as well as graduate students, and a few staff apartments as well. Next slide, please. This project would absolutely not be possible without a team capable of people delivering it in the right way. Capstone built an experienced team that could actually deliver on Passive House, and that was very clear all the way from their RFP response early on, and has proven itself through where we are today. Just a couple of months ago, for example, I got to watch this team in action, as you see here, Stephen Winter Associates, testing the air leakage of a window in the building. And we had the whole team on site. We had the construction company, PC Construction, SMRT, and all of the other subcontractors standing by, ready to troubleshoot as needed. The goal for this test was 4 CFMs or lower, and we scored approximately 1, which shows that we are definitely on the right track and that all the due diligence has been done along the way to make sure that this is a really tightly built, well-built structure. And I just point that out because so much goes into a number like that behind the scenes, with the very careful design from Elkus Manfredi and SMRT to the special training sessions that Stephen Winter Associates holds, to site inspections, constant communication and collaboration that's required between all parties. So having a good team has been critical for us. Next slide, please. So why did we do this? Why did we, the University of Southern Maine, decide to build Passive House? Really, it speaks to our vision for sustainability, and that it's not just a vision for being more environmentally friendly, but also a social and economic sustainability vision as well. So the vision is articulated in our 5 priorities for the next 5 years as an institution. One of those priorities is to, quote, transform our campuses with a focus on sustainability. And the most tangible action embedded in that goal is to be a carbon neutral campus by the year 2040. So what does that mean? Well, it means that our net contribution to greenhouse gas emissions from our operations would be negative when you account for everything we can actually reduce on campus, paired with a purchasing of carbon offsets for everything that we can't reduce. Building to Passive House directly impacts the carbon efficiency of our buildings per square foot, which essentially helps us to take a big step toward our goals of reducing heat and electricity consumption. Then on the other side of the equation, the economic and social sustainability reasons for this project basically go hand in hand with each other. And they relate to another one of our 5 priorities as an institution. And that priority is to lead on equity, inclusion, and belonging. So to kind of explain how this all ties together, when I was considering which certification system to advocate for the new building in my role as sustainability director, I really had a difficult time rectifying the really noble goals of the various broad spectrum green certification systems out there I won't mention them by name, but you know all of the other systems. I had trouble with those systems because of their high price tags to implement. And then in, you don't necessarily recoup that all in savings either. Sometimes you do, but sometimes you don't. So when you look at it from a total cost and total payback perspective to the owner, those costs also get passed on to the occupants as well. So this is where equity becomes really important to consider when you're choosing your certification system. I was intrigued by Passive House because it was based less on the bells and whistles and more on the actual performance of the building. And this really, this memory sticks out in my mind as being a critical turning point for me personally on this issue. When I took a tour of the Bayside Anchor building that's in Portland, Maine, I saw this all come together because it's a Passive House certified building, but it's a low-income housing building, and it needed to be built to be affordable from the beginning. They couldn't spend more money than they were going to get out of a low-income housing project. But they wanted to build high quality too, because they wanted the folks in the building to be living in a high quality building. So the cost per square foot of that project was just as reasonable as a normal building project, and they were able to deliver quality housing for folks in need. And that's when my mind started turning, and I thought, there's a lot here. Low cost housing on our campus is arguably our single most important objective for meeting the needs of our students, because one, housing is incredibly expensive everywhere these days. But the Portland, Maine metro area is among one of the most costly. And it happens to be the most diverse community in Maine, which means there's a further equity issue there. And our students are typically working class students. Many of them have full-time jobs. Some of them actually have multiple jobs. And out of the 60 plus students that I have directly supervised in the last 5 years, more than 90% of them have a job working 30 plus hours per week that they have to actually go to while taking full-time classes and fulfilling work study obligations working for me. Some of these students are lucky enough to get housing when they are freshmen and sophomores on one of our inland campuses up in Gorham. But when they move out of that semi-rural area, they try to move to Portland and they find that they can't afford housing. So what happens is many of them drop out and they don't finish their education. So what we realized is that we had to build affordable housing for them to be able to participate in this rental market and be able to actually find housing, and that this was an equity priority because it benefits not just the students, but it benefits our revenue stream as well. So instead of building a certification system with lots of bells and whistles and a long payback, we needed to build one with a short payback so that we could keep our operational costs low and keep the room rates lower than the market rates. So Passive House really fit this need. Next slide, please. So I really see Passive House as a pragmatic, blue-collar sustainability certification option. And if we can do it as an underfunded public institution, then any institution can do it in the United States, in my opinion. This project is on track to be the second largest university Passive House building in the country. And given that that other regional public universities haven't yet built to this scale, we're actually hoping that this project can be an inspiration to them, because there's a mega need for affordable housing on a big scale to meet this nation's housing constraints for those who are housing insecure, not only in higher ed, but through all of society. So if we can realize that we can actually build big Passive House buildings where the price point is kept very low with economies of scale, as Walker will speak to, then this can address some of the equity issues that we face in housing. Next slide, please. So last thing I'll speak to is just how did we turn this idea into reality? Once we decided we were making this building passive house, the next challenge was actually sticking with it. And I'll say that we were smooth sailing for several months, but that didn't last long. Like all university projects, the reality of a tight budget really began to sink in for us. So what did we do? We developed a VE list. Passive House was then added to the VE list. And it was the biggest item on the list. Therefore, obviously, it became the biggest target. So after VEing everything else that we possibly could stomach, we hadn't reached the number that we needed. So Passive House landed on the chopping block. And within a couple days, the committee that I serve on decided tentatively to cut it. I was heartbroken, and I felt powerless in this situation. I was a member of this committee after all, and I had done everything I thought I could to try to save it. So over the next several days, I'll be honest, I had trouble sleeping. I thought there's got to be a way to convince my colleagues to pursue this, despite there being, a cost premium. I reached out to my professional network to find every example I could of other institutions that are building Passive House and why they decided to do that. I reached out to all my local contacts as well who had done Passive House projects in Maine. And I put all this material together in a memo. I included as many provocative quotes as I could from developers and owners. I included payback calculations. I circulated this to the building committee. And the result was I did win over a few people, but it wasn't enough. The votes weren't there. So the next thing I did is I took a risk and I went above my boss and their boss, and I went directly to the president. And I knew the president had done his doctoral dissertation on sustainability, so I knew he cared about the environment. And I also happened to know at the time that he was reading the book, The Sixth Mass Extinction by Elizabeth Kolbor. So I said, you're reading about all these terrible effects of climate change in this book. And now we have this unique opportunity to actually do something about it that's right in front of us, sitting in our lap. So I said to him, if you are our president with a background in sustainability, and I'm a sustainability professional of 10 years, and the two of us can't figure out how to build a Passive House building at a university, then who will? Who will ever have the courage, if not us, to do this project? And what does that mean for society in this global challenge of climate change that we face? So the next morning, he called me on my cell and said, the steel is in my veins. So we were going to do Passive House regardless of the upfront cost, because in the long run, it is the financially sound way to operate. So without President Cummings' leadership, we wouldn't be here today presenting to you. So I thank him for that. And now with that, I'll turn it over to Walker to talk about how we actually got this done after we decided we were going to do it.
Thank you, Aaron. Hopefully those insights from Aaron gives you all a sense of the amount of planning, synthesizing, and corralling of stakeholders that it takes to put together not just an RFP, but then to execute on that vision. And that's really just looking at it from Aaron's perspective as the Director of Sustainability. And there's so many stakeholders that are involved in these P3s, and that's really where our role as developer, comes into play. And we try as a on-campus housing primarily, P3 partner of our institution to try to take the university's vision, hear from all the different stakeholders, and try to get everyone rowing in the same boat towards the common goal. And in this case, as we received the RFQ and then ultimately the RFP from the University of Southern Maine, it was clear to us that sustainability was high on the list of priorities for this institution, and also to serve the affordability goal of its students. So from our perspective, that was really one of the most important things we could do, is put together a team that could help to deliver on that vision. And Passive House, while a goal mission in the RFP, it was not a requirement, but we could tell that would be a difference maker, for selection. So we worked really hard to assemble a team of design, construction, and sustainability professionals that had the right balance of local and national expertise, and a willingness to commit to a purposeful evaluation of Passive House early in the procurement phase. That team, as you can see here from the logos, Capstone Development Partners as developer, Elkus, Manfredi, and SMRT as architects, PC Construction as our general contractor, design builder, and Stephen Winter Associates as our passive house design and engineering consultant. So once we had assembled this team, how did we really accomplish this? Well, SWA, with their extensive knowledge of passive house certification, really helped identify the outline spec and design assumptions that the design build team would need to reach the tight envelope and ventilation goals required by the Passive House Institute. From there, we were able to provide high-level cost allowance within our proposal submitted to USM in response to the RFP. But the reality is our GC underestimated some of those premiums at this early phase. And it wasn't really until a more detailed energy model could be completed during schematic design, post-selection, that really the goal of Passive House was more definable and ultimately determined to be attainable. So how much of a premium is Passive House? For this project, I think Thomas will tell you a little bit more about this, but his experience says the premium can be somewhere between 3 and 5% of the direct construction costs. For us, it was a little closer to the 5%. I think some of that is probably due to some regional challenges up in the Northeast and in Southern Maine. But ultimately, we were looking at somewhere in that $2.9 to $3.2 million worth of construction cost, and which included, upgrades to glazing for triple pane windows, and that's curtain wall, storefront, and punched windows. We had mechanical improvements for the VRF system and the packaged ERV system for outside air ventilation, plumbing, hot water generation and distribution, electrical. We had occupancy sensors, dimming switches, and sealing of all the rough ends. And then the envelope, of course, has both foundation slab and exterior wall and roof insulation. And then you have the other sort of during construction and post-occupancy or post-construction measures for testing and things like that. And then ultimately you had soft cost, engineering, both to have all the consultants and to just like you would have for LEED, but even more so because, Passive House is a little bit newer, at least here in the United States. So there was a few $100,000 premium there, bringing the total cost to about 2.9 to 3.2 million, not taking into account any savings that you might achieve for having panelized on-site construction that would reduce your GCs and GRs. So how long does it take to achieve economic payback? So the represented 5% capital budget premium for this project, while that sounds large, I think ultimately the larger the project, the higher the efficiency typically will be. And I do believe those premiums will start to come down here as we move into the future. But, for this project, as you can see from this table, that represented about a 15 year payback. But that really assumes, a 3% average escalation of operating and utility expenses, which, as many of you know, especially in this inflationary environment, some of those expenses are increasing greater than ever before. So as we looked at Passive House and talked about, as Aaron noted, the VE and what that could mean, and thinking about just a more simple payback like this, we all had to sort of dig deep and really try to better understand and project where might we be being conservative here in our projections, and where would the opportunities, not only near term, but really for the long-term operations and ownership of this project, really start to pay off and help support that affordability goal. And, as you think about a 73% decrease from, the ASHRAE minimum baseline design is so significant. And, $175,000 a year seems like, pretty substantial savings. But I do believe as you see those utility costs start to increase over time, the payback will be even shorter than, anticipated here on this slide. So the good news for our project was that we did enjoy economies of scale. As I think Aaron noted, this is the second largest Passive House student residence in the U.S. So that gave us some purchasing power with vendors as we received some of the early supplier and vendor quotes. They were a good bit higher than what we had been anticipating. And so we partnered with our team here, went out and talked to several of the vendors, tried to negotiate with them, explaining that not only do you have an institution here that's part of a larger university system, and then also a national developer and national architects that will be hopefully going on the road as we are today, or virtually as the case may be, to tell our story to others and try to spread the word about the benefits of Passive House. That we believe that there could be real marketing value in trying to be out to get out in front of this and be our partner. And thankfully, we did receive favorable feedback from a few suppliers, specifically the Simcoe ERVs, and then Intus and Alpine Windows worked with us to find a price point that would work for our budgets and help us meet our goals. And then finally, really just want to make sure that I emphasize that as you look at that Passive House premium, a lot of the items that we talked about there aren't things that have to be replaced at all, or at the very least, only after maybe 25 or 30 years. If you think about windows, you might replace the windows after 25 or 30 years, but primarily the south-facing ones that take the most, the most beating from the sun. All of your insulation and envelope and wall materials are going to be there for the life of this building. So you're not going to be replacing those as part of your CapEx program. So what does all this mean for the applicability of Passive House for the future? How can we achieve the equitable implementation of Passive House? As I think back to, I've been working in this industry for, almost 20 years. And when LEED first came on the scene, especially in higher education, there was a premium associated with a lot of the materials and with some of the upgraded HVAC equipment that we were needing to purchase to reach some of the energy and environment goals, that were captured under the LEED scorecard. And as time went on, 2, 3, 4, 5 years later, there was really minimal premiums for some of this equipment. It really, as it became more prevalent and green and energy codes around the country started to catch up, the demand increased, the amount of suppliers and manufacturers in this marketplace increased, and the cost came down. I think you're going to see the same thing here for Passive House. I think you're going to see these premiums come down as you see more implementation in major markets around the country and the world. Additionally, as I think about this project from just a purely a student housing P3 perspective, 580 beds is a good size project and did enjoy economies of scale, but many of these projects are even larger. 750, 1,000, 1,500, even 2,000 bed projects are not uncommon in our industry and can enjoy even greater efficiencies and economies of scale. So hopefully a lot of you are interested in trying to bring Passive House forward and make this equitable for all. But with that, I'm going to turn it over to Thomas and let him talk a little bit more about the details of the engineering and analysis that we went through in trying to achieve Passive House for this project. Thomas?
Perfect. Thank you, Walker. For the Passive House audience and the more technical audience today, I wanted to sort of first start by describing the major building systems at University of Southern Maine Portland Commons. And then we'll get into some more details about how we actually delivered this design. So the enclosure here for the dormitory is a panelized exterior insulation system that functions both as the air barrier and the thermal enclosure. It's from a vendor named Armorwall, which John will describe a little bit more about. The heating and cooling system is a high efficiency VRF system using heat pump technology. The ventilation system is comprised of 3 central roof mounted ERVs, and the domestic hot water production is completed with a central gas domestic hot water plant. I think as Walker mentioned, lighting is 100% LED in this project with sensors for all the common areas. And the appliances within the student apartments are actually all Energy Star certified. So those are the major systems within the building, and that's how we, that's how we made Passive House certification criteria work. But I want to highlight sort of how we actually delivered this design and what about our design process it was that made this project more cost effective for USM. So I'm going to highlight some of the actions we took to make this design work for USM. So starting with the integrated design process, SWA, Steam Winter Associates, as the Passive House consultant, joined the team very early in the design process, and we provided a fair amount of feedback on the feasibility of Passive House actually during the RFP submission. And then we worked on schematic and design development energy models to confirm the performance requirements for Passive House. We're actually able to work through the costs iteratively. So during schematic design, the Passivhaus consultant worked with the architects, the construction manager, the development partner in Capstone, and the university on some of the budget iterations. And what was key here is that because we were an experienced Passivhaus consultant in larger buildings, we were actually able to provide some constructive comments on the budget. So there were some areas of the budget we were actually able to sharpen up a little bit, so that we saw some vague high pricing related to the implementation of the air bear. We were able to sharpen that number up a little bit. And then for specific technical aspects related to Passivhaus, like aerosealing and aerosolized spray applications for ductwork, we saw some high numbers for that. We were able to bring that quote down a little bit. And I think what was key during the schematic phase was that the construction manager was actually on the team as well from the start and was helping cost the project in real time. So we, as the Passivhaus consultant, provided reports on the component requirements to meet Passivhaus, and the construction manager priced those out for comment by the team. That fostered, in my opinion, a lot of contractor buy-in during the schematic design process and just alignment of incentives. And we were able to work with the contractor throughout the design to, which I found as well, uniquely created a great sense of teamwork. So the contractor was providing some feedback on the Passivhaus design elements and the performance requirements, and we as the Passivhaus consultant were providing a lot of feedback on costing. So in contrast, I've worked on a lot of design bid build structures where we actually don't meet the construction manager or the contractor until the bid is actually won. In that scenario, I find the Passivhaus consultant and the contractor can sometimes be at odds in relation to the performance, the detail implementation, the design, and the cost of the project. But in this case, we actually were able to work together from the start and sort of work those issues out so that when construction started, everything was very smooth. We, as the Passivhaus consultant, we also identified what we thought would be the major cost upgrades associated with meeting the Passivhaus certification criteria. So we knew from the start that the window system and the ventilation equipment would be the biggest additional component costs. In other green certification programs, the windows would probably be a double pane system, but the Passivhaus comfort criteria pushes you into a triple pane system in this climate location. So we knew the upgraded triple pane windows was going to run a premium. And also potentially in other green building certification programs, the ventilation system may be more exhaust based, but Passivhaus pushes you into a balanced ventilation system with heat recovery. So there's some added components there for the ventilation system. So knowing that those were the two biggest line items from the very start was valuable. We were able to scrutinize the performance of those as well as the budget of these line items as much as possible. And we paid extra attention to how the specifications were written for those particular components so that we weren't locking ourselves into a closed spec or locking ourselves into one component or one vendor only. For the project manual and the specification book, to help control costs and foster some competition, we developed open specification language for major components. We didn't want to force the team into only one vendor or one choice. So the specifications were written with as performance-based with a basis of design product included, but then we had equivalency language so that if there was an equivalent product that could meet that, we could also consider that for implementation into our design. And this paid dividends on our two most expensive components. So there were two major window vendors looking to win the window bid. And because the window specs were written in an open format and performance-based, we actually had some competition between those two vendors, and the winning vendor had a price that was about $100,000 less than the next best price. Mechanical specifications for the ventilation equipment were also written as performance-based, which allowed the team to shop around for different ventilation equipment options. And for the ventilation system, at about 50% design documents, we were faced with a pretty major financial decision related to the ventilation equipment and the Passivhaus premium. We had to decide whether to proceed with a Passivhaus Institute certified ERV unit that met our performance requirement, or take the path a little less traveled and try to develop a custom solution that was better aligned with the university's budget and also could meet the Passivhaus performance requirements. So we worked with another vendor to provide to verify the performance rather of a non-Passivhaus Institute certified energy recovery ventilator. So we worked with a vendor named Semco. SWA gave the performance spec to the vendor. Semco provided several options that could meet the manufacturer's several options with performance data according to the AHRI testing protocols. And then SWA actually took that data, and we were able to rework their calculation methodology into the Passivhaus Institute's calculation methodology, and got our Passivhaus certifier, the Passivhaus Institute, to sign off on the actual calculation and performance of that equipment. So this, for me, was an example of an experienced team in a highly integrated way solving a problem. We had the Passivhaus consultant, the mechanical engineer, the vendor, the development partner in Capstone, and the university all working together to solve this problem. We're really able to utilize the size, the scope, and the visibility of the project to help control costs for this particular set of components. In the end, Semco provided a higher performing ERV, but at their original estimated cost. We also used a very efficient domestic hot water distribution system that saved both first cost for the university and improved the net operating income by reducing operational energy. So the typical domestic hot water distribution system that gets installed is this 3-pipe system here on the left. That's characterized by an express send with a horizontal distribution, a vertical distribution up, and a vertical distribution down, and then a long travel back to the original boiler plant. In contrast, we used a box domestic hot water distribution system, which has an express send, vertical distribution, a vertical riser, and then balancing valves and collection at the top, and then just a shorter run and horizontal return back to the boiler plant. So this type of system has a host of benefits, but it's really a single investment with multiple benefits. From a first cost perspective, we're able to decrease the recirculation pipe length by about 30%. So that saves on just the sheer amount of linear feet of copper that you're installing in the building. It also saves on labor. But from an operational energy perspective, we're actually able to decrease the domestic hot water distribution losses because we're reducing the surface area of the piping in the building. That in turn decreases the domestic hot water energy demand on an annual basis. And in the summer months, we have less waste heat going into the building, so the cooling demand is actually lower as well. So we're able to save on first cost and save on operation costs. So it's a multiple benefit to the operation of the building over time. And finally, for the wall assembly, the above grade R value requirements here in Portland, Maine were actually fairly high. Remember, we're in climate zone 6, actually in Portland, Maine. It's pretty far north. So we were targeting an R28 effective wall assembly. And to achieve that R28, we're really relying on a panelized wall assembly designed with continuous exterior insulation from a company called Armorwall. And John will get into more of the benefits in terms of sequencing and detailing, but from a pure Passivhaus perspective, this system is great because, at a very high level, we're sequencing together the installation of the air barriers and the control layers in a controlled environment off-site. And that exterior insulation is also good for mitigating thermal bridges, passes over the slab edges, and the attachment components for the rain screen system are able to be fastened directly to it. So we're able to thermally break the rain screen attachment system from the actual steel stud backup wall. So I'll let John explain the Armorwall panel system a little bit more. And thanks.
Thank you, Thomas. First, I would like to say that just reiterate what Aaron had said at the beginning about how collaborative this process has been. Obviously, Thomas has been a great asset to the team, but also our associate architects, SMRT, from Portland, have been great partners with us, and we've actually integrated our 2 design teams and worked together as a single team on this project. So it's been a really rewarding process, and the system, as Thomas began to describe, is very simple. Long before we got into the supply chains and volatility caused by the pandemic, we knew that we wanted to create a system that used local common materials that would be easy to fabricate in the shop and install in the field. Part of the magic of Passivhaus is the precision with which you can fabricate things and seal things to reduce the thermal barriers, to create the thermal barriers, reduce the thermal transfer, and to seal all of the joints. So having this very simple system, which is a cold form metal stud with some insulation in the cavity, and then this Armorwall system outboard, and create that very clean drainage plane you see there from the window to the face of the building, past the slab edge and on down through all 8 stories of the building became kind of a paramount design driver for us. And the next slide, if you will. The system not only allowed us to fabricate all of the joints, most of the joints of the armor wall in the factory and seal them in the factory, it also gave us an inherent advantage in that the whole wall, the structure, the bearing capacity, the insulation, all arrives to the site fabricated in the factory. And as you see here in this construction photograph, there is no on-site stick framing. The lateral bracing you can see with the steel, but all of the load bearing of the walls is taken care of by this system. So we have one building system doing a lot of different work for structure, for passive house, and for creating the window openings. The windows are installed on site. If you go to the next slide, you can see how these panels are literally picked and placed, and then you come back and you seal the window. All of the flashing and the vapor barriers around the window are installed in the factory, and then the windows actually come with a 1/2 inch tolerance on each side. The window is slid into the opening and then field sealed using backer rods on both sides and a foam sealant around the window to create that tight air seal. And then if you go to the next slide, I think, as Walker has already pointed out, in addition to the simplicity of the system, there's tremendous cost savings in terms of the time of the schedule, because these wall panels are load bearing and there's no framing phase to speak of. These panels could be fabricated while we were still working on the podium and on the foundation, and then delivered to the site. And PC Construction estimates that somewhere between 2 to 3 months of construction time was shaved off of the schedule as a result of prefabricating these panels. Also, as Walker pointed out, any additional cost that we spent to super insulate this wall is a single time cost. It serves the life of the building. It never has to be renovated or replaced. It is a single cost that has a perpetual payback in terms of its energy savings. So for us, the system really made a lot of sense. And the final thing that I would say is, just lessons learned. When we use a system like this that has all of these prefabricated panels arriving to the site, clearly sequencing and having them delivered in time to keep the project moving is a very important thing. But having all of the slab edges aligned, because this system bears on the slab and then has to go past the slab with the insulation outboard, it's very important that the slab edges align along the horizontal of each floor, but vertically as we go up the building. So the contractor had to have incredible quality control and field surveying as they place these concrete planks that bear on these panels. And then I think, Thomas, you have one slide left.
Thanks, John. So as you can see, we're in the process of construction today, and I'm happy to say things are going well, given our first on-site inspections that we've done, our first testing of the windows for air infiltration. But that's no accident, really. We developed a number of quality assurance tools to document the performance of the building for final pass-fail certification. So first and foremost, we developed this typical inspection tool to verify the implementation of sort of the common air bear and thermal details, like the panel-to-panel joints on site. We also developed a unique inspection checklist, and that's to verify sort of the implementation of more unique details in the building, like mechanical roof penetrations, the things that may happen once or twice throughout the building design. And we also were very open and direct with the contractor about the expectations for the final blower door testing. So we have written in the blower door testing performance requirements into the actual specification, and then also provided the contractor a blower door test plan to make sure that the building is ready for final air infiltration testing and that final blower door performance test that's needed. So all of these tools and checklists are really there to confirm that the USM Portland Commons, that building will perform as designed, and the university will realize the energy savings and the performance that they've invested in. And we're happy and thrilled really to expect final pass-pass certification in 2023, and very hopeful that this design can be an example for other institutions moving forward. So with that, I'd welcome any questions to the group here.
Well, good afternoon, everybody. What a fantastic set of presentations on this incredible dorm project. My name is Monty Paulson. I lead the Passive House team at RDH Building Science, and I work as a climate change specialist at RDH Building Science. We've worked on a couple of dorms ourselves, one in Toronto, one in Victoria, and one completed in Kelowna, BC, so we can relate to some of these challenges. There have been a few questions in the chat. I think we'll start with maybe you, Thomas. There were some questions about how we set the baseline and how we projected the savings. And kind of how that played out. Do you want to tackle that first?
Sure, no problem. So I guess we'll start with the baseline and our baseline assumptions. So we developed a PHPP model that reflected the passive house design, and we wanted to estimate savings from there. But you have to establish a baseline. So what we did is we talked to the university as well as Capstone as what the goals might have been if passive house was not the sustainability goal. And from that, we were able to sort of tease out that a lead sort of silver or bronze might have been the goal, but USM was more ambitious here. So from that, we looked at ASHRAE 90.1, and so we basically created a second case from our PHPP passive house model, and we sort of eroded the performance of the passive house model down to an ASHRAE 90.1 level. And ASHRAE 90.1 gives you all kinds of guidance about what the enclosure R values have to be, what the UWs have to be for the windows, what the ventilation equipment efficiency should be as a minimum. And so from that, you can develop a pretty robust second baseline case. And then you just compare sort of the site energy between those two cases, and you can establish an annualized savings and utility costs per year. Relatively simple exercise, I found.
Yeah. Another question I'd love to hear more about is what sort of barriers you faced at the city of Portland, which is a relatively small city. This is also a project that was really at the interface where single-family homeland enters into downtown, and so it probably got more scrutiny than some other 8-story buildings might have received. To Kristen first, and then maybe Aaron, what sort of challenges were there in getting this thing permitted? You want to unmute yourself, Kristen.
Yeah. Thanks, Monty. That is a great question, and honestly, dealing with the city it's a never-ending surprises, I guess. The several challenges. This is a big building. I mean, this is a big building, even if it wasn't passive house. And so you've got 1B construction type. So we have construction type challenges. Then you have the NFPA 285 challenges, right, which is how the flammability of your exterior skin materials. And then we had, I won't say challenges of passive house, but the novelty from their perspective, I would say, of applying passive house to larger buildings and having them understand, the intent and the rationale behind, this 4-inch thick armor wall panel, right, which is doing all these wonderful things, but the panel, is not tested as part of an assembly. So we've got this, 1B that's requiring all sorts of fire ratings. And then we've got this panel that's not tested. It's not a UL thing. And that makes them all sorts of nervous. So we had to go down the path of getting, letters of authorization and digging into the science of all these components to make them feel comfortable. And it was enlightening, challenging, and I'm really hoping it's going to lead the way and make everybody else's life, a little bit easier as we move forward with this. So that was a bit from my perspective.
How about you, Aaron? Did the university face welcome responses or uphill challenges with the city?
So I think the city, at least the planning board, which is who I interacted with the most, they're very pleased to see that we were trying to build passive house because it fits into their climate action plan as a city. They have a robust climate action plan that they just published 2 years ago. So it really meets that agenda nicely. I think what it was basically was a educational process of, if we do passive house, we can't do this or that. We can't, because they're spending a big premium in passive house, we can't do some other bells and whistles that the city might like. And also one of those, for example, just to put it into perspective, is solar. They said, well, why isn't there a bunch of solar on the roof? Isn't it a sustainable building? We're like, yeah, but there's not a lot of room. We have these heat pump units. We have to have these air ventilation systems in place because it's such a tight building. And frankly, there's just not enough room at the end of the day. So that type of education was really important.
What's the construction schedule, Walker or Aaron? Where are you at now, and where do you anticipate being over the next year or two?
Good question. We started construction in February of 2021. After going through the entitlement and permitting process there virtually through Zoom, there through the city of Portland in late 2020. And we are just over the halfway mark, I would say. Well over, I guess, now, because we're just under 1 year from completing. We will complete and be open for occupancy June 1 of 2023.
Great. I'll offer this kind of suggestion as a city that's gone through several phases of passive house. It's tremendously helpful if the first large project like this does lots and lots of tours during construction. The biggest gift you can give to everybody else in the community is having other constructors walk through and say, this is not hard. I could do better than this. When they have that reaction that it's not so hard, that really propels the way forward. So if that's within the means to do and within Means University, that would help. Aaron, you said something in your presentation. Sorry.
I was just going to speak to that a little more. That's such a great suggestion, and I really appreciate that. And one thing I'll just say on that note is that we have been starting to do more tours. We're starting to reach out to classes, but there's two things in particular we wanted to do because passive house is such a hidden certification, where it's hard to see that a building is passive house, whereas some of the other certification systems it's more visible. Two things we've done to make it visible include, first of all, we worked with Stephen Winter to develop like a drawing that kind of shows the layers of passive house and explains the science of it. And that drawing is specific to our building and the systems that are in it. And that's something I've used in classes. It's something we've used in marketing material. And another piece of that is just, giving lots of tours and also taking pictures along the way of the building as it's being constructed. The things that are going to be invisible once the building's done, having images of that, the insides of walls, the extra caulking, the thermal barrier, those things, I think will be really important material when it's all said and done.
Yeah, it really is. Welcome, John. I was glad we were able to get you in here as well. I want to ask one more question of you, Aaron, and then we'll turn to John for a second. In your presentation, you noted that you intentionally put passive house in the value engineering discussion, which strikes me as a very gutsy strategy through this whole process. We've worked with several projects to make sure that passive house was required as part of the brief, but then had robust discussions in value engineering about how to achieve it. Had we picked the right wall system? Had we picked the most affordable window combination? Had we picked the most affordable ventilation combinations? What led to that decision, and how do you feel about it afterwards?
I would say that we probably put that on the list, much to Aaron's chagrin.
Yeah.
Whenever a project gets in trouble from a budget perspective, as a developer, we owe it to our partner in an institution like USM to give them all the list and possible strategies to get back to budget. That just happened to be one of the biggest ticket items at several $1 million that we at least wanted to throw out there and say, this is something you consider. You could look at alternative strategies, but to Aaron's credit, he was steadfast, and so was the university, and we were able to ultimately find alternative ways to close the budget gap.
Yeah, that's helpful.
The only other thing I'll say about that is that, I've worked in higher ed now for 12 years, and it's the same everywhere I've been. Higher ed is not very as much forward thinking as they probably get credit for, especially when it comes to fiduciary responsibility. They're very short-term thinking in terms of finances. And I say that with all due respect for all the institutions I've worked for, but it's just, when there's a big ticket item, like Walker said, out there, like the certification, it's, almost always considered on the chopping block with every building project I've seen in higher ed. At one point or another, it's always finds itself on the chopping block. It doesn't always get chopped, but it's always part of the discussion because universities are willing to do anything and everything to reduce cost.
John, you were talking about the panelization system somewhat. Do you see what's being learned here is applicable to other projects?
Absolutely. One of the great things about housing is that no matter what market segment is, it tends to be repetitive, right? It's stacked, it's extruded, and it lends itself to panelization of all forms. And to be able to create a wall panel that satisfies these passive house insulation requirements is a pretty easy step, frankly.
Yeah, no, I think you're right. And what we're seeing is as more projects move to mass timber, which pretty much have to be built with hanging panels because you need to encapsulate quickly, the importance of the wall panel industry, it's actually the missing piece in the mass timber industry, at least in the Western United States and Canada somewhat. So it's a real key piece. I want to know, this is one of 3 dorms of approximately the same size being developed now across North America. There's one at the University of Victoria here in British Columbia, one at the University of Toronto Scarborough. There was a presentation about its kitchen earlier, and this one are all in that high number of room forms. Several have a couple L-shaped buildings like this. So it'll be really fascinating in a few years to monitor all 3 and see how their performance did and kind of learn from all of them as a set. There was a question in the chat asking though, and all of those are to the Passive House Institute standard. There's a question in the chat though, asking if you also looked at FIAS and if you weighed FIAS versus PHI for this project or other high performance standards.
Yeah, the short answer is yes, we did look at both PHI and FIAS programs. And our SWA does certify and design passive houses in both programs, as does Monty's team, I believe. At the time though, FIAS did have some benefits. We found like the thermal comfort criteria for the windows was a little looser. So the UW value didn't have to be so low. So that's a clear benefit. But overall, we found the cost of FIAS with that program version to be a little higher than PHI. And that's mostly due to the co-requisite program. So FIAS has Energy Star as a co-requisite program, Zero Energy Ready Homes, and Indoor Air Plus as a co-requisite program, which requires additional testing on site and quality assurance and quality control on site, which I think is a good thing and should be included in the project if it can be. But this project was particularly cost sensitive from a first cost perspective, particularly. And so PHI kind of won out in that regard. But I think both PHI and FIAS programs are great and deliver an excellent product and an excellent building. I don't know if Monty, you have anything to add there about sort of how your team evaluates PHI versus FIAS or not, but for us, it was purely cost-based in this particular circumstance.
Before Monty answers that question, I'd just like to clarify one thing. I mean, I think the one reason this project was so cost sensitive is because we're really trying to deliver an affordable residential on-campus student experience for students. So passive house, we could see the payback. We could see the ability over time, over decades of operations on this campus, that you're going to keep operating expenses low. You're not going to repetitively install and replace some of the passive house measures that we've installed. So it's going to be, dollars up front that really pay off for many, many years. Whereas some of the other certification programs have some benefits and tangential benefits and certainly environmental impacts, but not necessarily the direct affordability, impact that passive house did to students.
Yeah, no, I think that's a really good point. We've been dealing with the effects of climate change pretty intensely. And so we're starting to look at resiliency over a 50 to 100 year time frame. And we feel having a solid enclosure, like a passive house grade enclosure, provides additional resilience, especially if you have coinciding like a heat spell and a power out, or a cold snap and a power out, which is in fact the most likely scenario. The ability to achieve high resilience and survivability, we think it goes up an awful lot. I'm curious, Aaron, how the rest of the university views the project. Is it viewed as something to celebrate? Or is there competition among other departments or other bureaus? How is it viewed at the university at this point?
That's a great question. I mean, mostly folks are celebrating it. I think everybody's celebrating it at the university. They just maybe don't really understand what Passive House is yet. And it's something that, we're trying to get out there and explain it to people. Like I said, I'm trying to get into the classroom. Every committee that I serve on, whenever the building project comes up, I mention that it's Passive House certified because, there are a few people who understand it. And if we're not in the room, the word Passive House might not come up in the conversation, which is unfortunate because it is such a large Passive House project and it's pretty special. So we like to talk about it. But yeah, I would say there are some questions as some of the other buildings are getting developed on campus, because right now we're looking at about 5 buildings. And there are some questions of, can our building be Passive House certified? Why are some buildings LEED and others Passive House? And those are great conversations for us to have with the university. I definitely think, in terms of the efficiency of Passive House and the expenditure, it's easier, for buildings that have some smaller spaces. Lots of small spaces is a great model, but some of these other buildings that have, large glass facades and big open spaces, and they obviously don't lend themselves as well to the Passive House design, at least from a cost perspective.
I know that both the University of Toronto at Scarborough campus and the University of British Columbia at Okanagan, which is in Kelowna, British Columbia campus, have several LEED buildings and other high performance standard buildings that they've worked through other standards before they got to Passive House. And they have the benefit going forward that they can compare performance of, in Kelowna case, a similarly sized LEED dorm on district energy with a similarly sized Passive House dorm on air source heat pumps. And that'll give them a lot of data going forward to see what really works. We don't have a lot of other questions in the chat. Is there anything else any of you would like to ask one another, or points you wish you'd made in your presentation that you want to pipe in and add now?
I would ask Walker. Capstone's actively engaged all around the country. We've talked about how unique this project is. He has probably vetted and maybe interviewed and maybe even won 6 or 8 commissions since this one started. What are you seeing nationally, Walker, about, and especially in the South? You do a lot of work in Florida, Texas, Denver, West Coast. Is this catching on in higher ed?
It's a great question. To me, what I've noticed is that the expectation for sustainability comes on every project. What is not necessarily always clear is what are the specific goals of an institution. We've seen a few that have, certain net zero energy goals by a certain time frame, or for their entire campus. We've had some who don't specify anything, but just say, tell us what you think are some interesting opportunities, and we'll share, our Passive House experience here at USM. But it's an interesting question, John. I just think, it really takes someone who, is interested in Passive House and, understands the goals and really what Passive House can help you accomplish as an institution, whether it's affordability, energy efficiencies, and the like. For that really to become prevalent and really something that can get off of the drawing board. We've teased it in a few proposals when it wasn't a requirement to say, hey, we'd really love to share with you our experience. And we haven't seen as many takers as I would hope. But I think that's going to change as more projects get done, and as we can start marketing this project and others, and really start to demonstrate the true operating cost savings. I think you'll start to see more and more leaning to it. I mean, it took LEED a little while to get off the ground as well. And the more that was achieved and the more the premiums came down, I think the more you'll really start to see it adopted with regularity.
Yeah, well, and that was a bit of a leading question, and I had the same experience, but our firm also does a lot of multifamily housing and close-in municipalities around Boston, suburban communities. And increasingly, that is a pressure point for the developers. The municipalities are really pushing them to provide all the new housing, all the multifamily apartments, the stick-built things that you see in the suburbs to be passive house certified. So I think it is coming, and it's coming in a huge wave, and I'm excited about that. And we share we say, you know, we've done this for student housing, we can do it for multifamily housing as well. It's not that different.
It's a great point, John. And again, as you think about those net zero energy goals that a lot of institutions have started to adopt, or, you know, carbon neutral goals, if you think about applying not only a solar PV array, as Aaron was, you know, noting earlier, with a passive house envelope and system, you could end up lowering your energy use so that maybe all you need is the roof mounted solar, because so many of the projects we've looked at net zero energy on, you need so much, you know, acres of ground mount, you know, in addition. And so if you could lower your energy usage to such a low, you know, peak, then, you know, the amount of solar you need to then offset that and become more carbon neutral is exponentially lowered. So I think they really go hand in hand. And there's a lot of infrastructure developers out there that would amortize the cost of those PVs if you could figure out the passive house on your own. And so you could kill two birds with one stone and really start to be uber sustainable.
We're finding a growing number of commercial developers and institutional developers are looking at 3 metrics from the start. First, what are your first costs? Absolutely. And how can you manage first costs down, especially in the current environment? Secondly, what are your operating costs? And looking at different systems that can higher and lower operating costs, not only energy costs, but also like how often do you have to change the filters? How often do you have to maintain equipment? And then third, resiliency costs. If we look to extreme climate coming in the next 20 years, will buildings need retrofits? Will they be able to survive difficult situations? Is it a building, say on a campus, that you can shelter in, or you're gonna have to move people out of in certain circumstances? So we're finding increasingly those are the 3 metrics people are looking at. And you're absolutely right, Walker, that passive house plus PV is a great formula for all 3 of those in most circumstances. And then I guess I'll end on this. I can't stress the importance of lots and lots and lots of tours. The architect, Scott Kennedy, of our first multi-unit project here in BC, ran pretty much a tour a week for almost a year and a half. He was worn out by the end, but people would come back, and many were just neighbors, many were other developers, other builders. It just, over time, an awful lot of people have gone through the building, and we still have developers and institutions who the first question, what's it like? And so we take them to some building and let them see a student suite or see a commercial suite or whatever it is. And it helps them get over the fear factor when they can see the actual cost, when they can see the actual savings. So you have, if what happens there is like what happened here, after those first couple 3 buildings, it took off, and we now have dozens and dozens of large passive house projects in the region. But it was because the first ones let everybody see what they were doing. So on that note, I think we're close to out of time. I don't see a note from our moderator, Vlad, but I believe, yeah, okay. So thank you, Thomas. Thank you, Walker. Thank you, Aaron. Thank you, Kristen. Thank you, John. Those were fantastic presentations. I'm hugely excited about this project, and I want you to host a passive house conference where we can all stay in those rooms some year in the future and come up and all enjoy the building. Take care.